Okay, so students, I am Assistant Professor Mr. Karan Kumar Das. Come back again. See, in my last two videos, I have uploaded the general description part of the alkanes and as well as the nomenclature part also. Okay, and in this video, I will upload the very important thing that how you can synthesize this alkane. Okay. Synthesize means how you can prepare this alkane. So there are actually lots of methods of preparation for the alkanes, but within your syllabus, I am describing you only the basic four methods. Okay. So first method is the catalytic hydrogenation. Catalytic hydrogenation of the unsaturated hydrocarbon. So first thing, what is the unsaturated hydrocarbon? In my last video, I have told, hopefully you have remembered, that alkane is what? Alkane is basically chemically inert. Why? Because it is a saturated hydrocarbon. Why? Because only there is the single bond is the present. Carbon-carbon single bond or carbon-hydrogen single bond. There is the no double bond is there. Okay. But unsaturated hydrocarbons are the such things where the carbon-carbon double bonds are present. At least one carbon-carbon double bonds are there. Okay. Those kinds, if the one carbon-carbon double bond is present in one organic compound, that compound is known as the alkene. Okay. Already I have uploaded that video, alkene. Already I have uploaded in my channel. You can see that video, alkenes. And alkynes, which is most probably not included in your syllabus. Alkynes, there are the at least one carbon-carbon triple bond. Okay. So, if we make the hydrogenation of the unsaturated hydrocarbon, like the alkane or alkenes, then it has been converted to alkane. Okay, just see. Okay, it is one unsaturated hydrocarbon. It is example of one alkene. Okay, if I make the hydrogenation of it, then it is converted to one alkane. The corresponding alkane has been produced. Okay, the double bond has been break and converted to the single bond corresponding alkane. Okay, and for this reaction, any fine catalyst has been required for the reaction completion. Okay, so here we will use as the catalyst nickel aluminum palladium or platinum. Okay, nickel aluminum platinum or palladium. This combination you can use for this reaction. Okay, next is done by the reduction of the any kind of alkyl halide. See, by reduction of the alkyl halide, there are basically two methods. One is the indirect method and another is the direct method. At first, I am describing the indirect method. The indirect method of reduction of alkyl halide. Why I am describing? Listen carefully. From this part, you can get one short note also or any MCQ also. What kind of MCQ? Very important point, a Grignard reagent. Okay, the Grignard reagent. Remember that point, Grignard reagent. What is Grignard reagent? Grignard reagent is nothing but one alkyl magnesium halide. One alkyl magnesium halide. That means, suppose methyl magnesium iodide. Here, methyl is one alkyl group, magnesium is, and in the halide group there are iodine is present. So it is one example of the alkyl magnesium halide. That is Grignard reagent. Okay. In your semester examination, you can face this kind of question also. Suppose there are the four options will be there, and your question will be which of the following is one Grignard reagent. Okay. At that time, your answer will be the methyl magnesium halide or ethyl magnesium bromide, that way. Okay. See, in this method, at first, when any alkyl halide has been react with the magnesium, in the first step of the reaction, the alkyl halide, okay, the alkyl halide, see, here R stands for any alkyl group and H stands for any halide group. Hopefully you have remembered that H stands for any halide group and R stands for any alkyl group. Okay, like you can write here methyl iodide, methyl bromide, methyl iodide, methyl bromide, so on. Okay, in the first step of the reaction, it reacts with the magnesium. In which medium? The very important point, either ether or THF. What is the full form of THF? The full form of THF is the tetrahydrofuran. Okay, you can react it with magnesium in ether medium or tetrahydrofuran medium, and after that the Grignard reagent has created. Okay, in the next step, if we make the hydrolysis of the Grignard reagent, then it can be converted to the alkene. Okay, if I hydrolyze it, hydrolysis means the reaction with the water. Okay, if I hydrolyze it, then it has been converted to the particularly alkene. Okay, it has been converted to the alkene. Okay, it has been converted to alkene. And along with that another compound. It is a side compound. It is not most important thing. The most important thing is this reaction with the magnesium in ether of tetrahydrofuran medium, and Grignard reagent has produced. By hydrolysis of the Grignard reagent, we will form the alkene. Okay, we will form the alkene. Or both are fine. Actually, doubler means I will describe it in the later. In the Cori-House synthesis method or Puig reaction, you can understand what is the difference between the RH and doubler. Okay, no issue for that. This is the indirect method. Now I am going to describe it the direct method. Okay, now I am describing the direct method of the alkyl halide. See, in the direct method there are basically three kinds of method. First method is the reduction by the dissolving method. What is dissolving method? Hopefully from the name you can understand that dissolving means it should be dissolved in any medium. Medium means any liquid medium. Okay, so what is the liquid medium? Liquid medium means any kind of acid or any kind of base. Like you can take the reaction of the alkyl halide with zinc gas in hydrochloric acid. Okay, you can choose the zinc with sodium hydroxide. You can choose the zinc in presence of the acetic acid. Okay, no issue for that. So see, it is the alkyl halide and it reacts. Suppose I am taking, okay, and the alkene is produced. Okay, the alkene is the produced finally. Okay, it is the first direct method. Next direct method is the reduction with the lithium aluminum hydride or sodium borohydride. Sodium borohydride or lithium aluminum hydride. Okay. Or sodium borohydride. You can choose any one from them, lithium aluminum hydride or sodium borohydride. Okay. By reaction of these two materials, you can find the final alkene. Okay. It is second reaction of the direct method. Now I am describing the last method. in the last method, you can react the alkyl halide either with the both with the hydroiodic acid and must be taken the concentrated hydroiodic acid. Not the reaction can be happening with the dilute hydroiodic acid. You take the concentrated hydroiodic acid along with red phosphorus. Okay, along with red phosphorus. Hydroiodic acid along with red phosphorus. Then you can also achieve the alkane. So it is the overall of the direct method of the reduction of the alkyl halide. Okay. Now this reaction will be very important reaction, which I am going to describe right now. Which is the name of the reaction? The reaction name is the Corey-Howe synthesis. Corey-Howe synthesis. Actually, scientist Corey basically it has been invented, and after that it has been right now very much popular method for synthesis of the unsymmetrical alkene. For synthesis of the unsymmetrical alkene. Corey-Howe method, which is very important for the synthesis of the unsymmetrical alkene. See, what is the difference between the symmetrical alkene and what is the unsymmetrical alkene? Suppose is it a symmetrical alkene or asymmetrical alkene? It is one unsymmetrical alkene because within this middle bond there are another alkyl group, another alkyl group. This is one example of the unsymmetrical alkene. Okay, this is example of the unsymmetrical alkene. So what is the example of the symmetrical alkene? It is the example of the symmetrical alkene. Okay, it is one example of the symmetrical alkene where within the bond two alkyl groups are same. That alkene is called the symmetrical alkene. And if the two alkyl groups are different, then these are called the unsymmetrical alkene. Okay. So by using this Corey-Howe synthesis method, we can produce the unsymmetrical alkene as well as the symmetrical alkene both. Okay, if in your examination in MCQ, suppose there will be the four options. How we can produce the unsymmetrical alkene, by which method? Your correct option will be the Corey-Howe synthesis method. Remember that one, the very important point. Okay, the Corey-Howe synthesis method you can use for the preparation of the unsymmetrical alkene. Okay. So, what is the basically Corey-Howe synthesis method? What has been happening in the Corey-Howe synthesis method? See, here dialkyl, one lithium dialkyl cuprate is necessary for continuation this reaction. Okay. Okay. See, R2 means one symbol of the alkyl group. Okay, so two alkyl group. You can write here. Okay. So what is the name of that? The name of it is the lithium dialkyl cuprate. Okay. So any lithium dialkyl cuprate you can use for this reaction. Okay. And in this reaction, remember the only reaction by which you can produce the unsymmetrical alkene. Sorry, I am writing here. Then you can understand the R and R dash. Listen carefully. Here I am denoted as the symbol R, but here I am denoted as the R dash. Why? I have already told you that what is unsymmetrical alkane and what is symmetrical alkane. And already I have told the point also that by using this method we can prepare the unsymmetrical alkane also. So these R and R dash may be equal to or may be not equal to. Suppose if R is the methyl, R dash may be the methyl or may be the ethyl or anything else. Okay? Maybe R or R dash can be same in this reaction or maybe different. If the R and R dash will be different, then unsymmetrical alkane preparation can be possible by this reaction. Otherwise, the alkane can be converted only the symmetrical alkane, not any unsymmetrical alkane. Okay. So polyhouse synthesis nowadays is maximally used for the preparation of the alkane because we can prepare here the symmetrical alkane as well as the unsymmetrical alkane. Okay. And all higher alkanes should be prepared by using this method. Okay. And most important point is that these reactions also happen in the dry ether. In dry ether or tetrahydrofuran. These reactions also happen in dry ether. Dry ether or TNG. Tetrahydrofuran or dry ether, this reaction can be occurred. Next reaction is the Wurtz reaction. The another name of the Wurtz reaction is the Wurtz reaction. Scientist Wurtz has been invented about this reaction. Okay. Due to that reason, the reaction has been named as the Wurtz reaction. So basically, what is Wurtz reaction? In the Wurtz reaction, two alkyl halides react with the two molecules of the sodium. How? You can ask me one question here. Is there are these are maybe different or not? No. There two are must be same, and due to that reason this process only can be used for the preparation of the symmetrical alkane, not for the preparation of the any unsymmetrical alkane. This method cannot be used for the preparation of the any unsymmetrical alkane. Only for the preparation of the any kind of symmetrical alkane. And this procedure is also happened in the medium of dye. Okay. In your semester examination, till now I don't know which kind of question can come there. But if the long type question has been coming, then you can found this type of question, write a short note about the Wurtz reaction. Okay. This kind of question you can come to. Okay. So remember one point. Here only symmetrical alkane can be produced. And another most important thing, here you can prepare the mixture of alkane, not for a single alkane. Suppose here I am taking methyl iodide. Okay. And here I am taking ethyl iodide along with the sodium. What will be our end product? There are the combination of three products can be happening there. What are the products? One is the propane, one is the ethane, and another is the normal butane. Already in my first video I have told you what is the difference between the isobutane, neobutane or normal butane. So combination of the normal butane, propane and ethane has been produced here. Okay. See, actually I told you the very shortly how mechanism has been happened here. Basically, see, you all know that sodium always bear a positive charge here. Okay, sodium contains always a positive charge. Okay, so here actually what will be happening? has been removed from here. Okay, this is the halogen. The halogen has been removed from here, and this attached to this sodium. So it has been formed halide because it actually any kind of halogen contains negative. Chlorine, bromine, iodine, every halogen contains the negative charge, and sodium is the strongly positive. So the strongly positive charge and strongly negative charge bounded to each other and combine the sodium halide. Okay, and due to that reason, what will be going the another way? There are the two are present. One is the bizer and one is the bizer. Okay, the sodium is the two molecule. One halide is taken from here and one halide is taken from here. So what will do this are? This are will definitely join with this. Okay?
Yes, sir.
There are the two halide, two alkyl halide group, and two sodium molecule is there. One halogen taken from here and one halogen taken from here. So two alkyl group is the bracket, and this two alkyl group join with each other and combine produce the alkyl. Okay? This is the overall the Woods reaction. Remember one thing, Woods reaction there are the lots of limitations. First important point, you cannot prepare methane here. Okay, you cannot prepare methane here. Number two, you cannot prepare any unsymmetrical alkane here. Number three, if this halogen contains any other group, like any OH group, COOH group, then the reaction cannot be possible. This is the overall limitation. Now, I am telling you some physical properties of the alkane. What are the physical properties? Already I have uploaded video about the chemical properties of the alkane, but what is the physical properties? See, there are the first important point is the boiling point, where the alkanes are the chain alkane. The chain, in case of the chain alkane, if the molecular mass of that alkane will be increased, then also the boiling point is also increased. That means the molecular mass is directly proportional to the boiling point of the alkane. Okay, the boiling point, the molecular mass is the directly proportional with the boiling point of the chain alkane. Okay, why? In the examination, this question can be done because if the molecular mass of a particular chain alkane has been increased, with that the total space, molecular space, that has been also increased, and due to that reason, van der Waals force has been also increased there. And to break this van der Waals force, we require the much more heat. So the boiling point is much more higher, as well much more higher in case of the chain alkane to increase in the molecular mass. Okay. In case of the chain alkane, there are the lower boiling point than the long chain alkane. In the side, in the side chain alkane. Suppose there are, it is N-butane, okay, and this is isobutane, okay. So the boiling point of the N-butane is much more higher than the boiling point of the isobutane. Why? The same thing, the van der Waals force, because from the structure, hopefully you can see that here the total space is the maximum higher, and due to that reason, the van der Waals force for the side chain alkane is much more higher than the branch chain alkane, because here the space is the low, space is the bigger, and due to that reason, the van der Waals force acts less than this. Okay. Next is the melting point. In case of the melting point, here the van der Waals force is responsible for the boiling point, and for the melting point, the crystal lattice force is the responsible. Okay. For the melting point, crystal lattice force is the responsible for the alkane. See, there are basically two types of alkanes we have considered for calculating the melting point. First is the odd number alkanes or odd number carbon alkanes and even number carbon alkanes. Even number carbon unfortunately, in the molecular structure, it has been not the straight line. There is a zigzag line. How? Suppose this structure has been happened in the original molecular structure of the organic chemistry. Okay, in case of the propane. Okay, this zigzag structure has been happened there, not this kind of straight structure. Okay. See, there are some basic difference between the odd number carbon containing alkane and even number carbon containing alkane. First thing, odd number carbon containing alkanes, both the van der Waals force as well as the crystal lattice force, both are the sum less than the even number carbon containing alkanes. Okay, both are the less, and due to that reason, odd number carbon containing alkanes has the lower melting point as well as the lower boiling point as considered to the even number containing carbon alkanes. Okay, and last is the solubility. What is the solubility? Solubility is same like another different organic compounds. It has been very much soluble in any kind of organic solvents, like the ether, like the benzene, so on. But it is the very less soluble or almost insoluble in water or any inorganic solvent or polar solvent. That's it about the physical properties of the alkane. And chemical properties already I have uploaded. You can see my channel there. Thank you. Hopefully my study you can understand that. So stay on home and study thoroughly. Good day.